for example, the DCS system or the QCS system, but they don't talk to each other. So you have something in the boilers which is not connected to maybe a pulp mill, which is not connected to the paper machine. This is the biggest problem. How do we centralize everything and make them talk to each other so that we can get a better benefit from that? That's the key. The extreme end of the journey is more about for each and everything, decision making, root cause analysis, control purpose. The data is being widely used. That's the extreme end of that. I would say that we have done many audits in the Indian industry. We have seen that okay, our journey is something in between 2 and 3. The stage 2 and 3 is something which is quite visible to us. So considering this aspect, we have defined a successful journey map, I should say, for the pulp and paper industry specifically. To start with the foundational aspects of that, it's more about capturing the data. I was just keep mentioning that, but there are challenges in capturing the data for sure. How often, what is the frequency, what is the resolution of the capturing, those things matters. But once you capture and historize it, what do you do with the data is more important, because just storing the data is just a waste of space. So we have to utilize that, making into more useful insights, which is coming from the process, which is very, very important. So the foundational part is more about that. So connecting everything, collecting it, storing it, and convert it into a useful insight. Useful insights in the sense it can be a good visualization. In the morning, we have been hearing from our keynote speaker also. A visualization really helps. I mean, it's not just fancy. Actually, what happens is like we have certain use cases which people say that I don't need to call the operator sitting in the pulp mill anymore because I'm seeing it in front of me, because it was not available in the DCS. Rather, it is available in a different platforms in a dashboard kind of setup. So that's one of the foundational element we'll be trying to do it. But having that visualization part also, we can extend that to a certain level of analytics, which is possible, like XY floating regression mechanism, linear regressions, and certain level of PCAs. Oops. Okay. Certain level of PCAs and PLS. Somebody was asking in the morning session what kind of modeling we will be doing. There are certain things already predefined which is available within the systems, within the tools which we will be discussing. But there are certain this system can be incorporated also. That's the foundational part. Once we have this is pretty much available with us, then the next immediate step is how do we make it profit from that? It's like economize that data and the usage of data into an automated control system. That stage is more of an AI system, or now it has been called AI. Earlier it was APCs, and sometime it is model predictive control system. So the concept remains the same. So how do we create a closed loop to achieve certain target by utilizing multiple variables, which is varying in the process. So that's the whole idea of having a profitable automation phase, which is phase number 2. The difference between phase 1 and phase 2 is a little bit need to be explained, because phase 1 can be mill-wide. I mean, there is no limitation. I mean, data has been generated from all across. So it can be mill-wide, and the benefit of that can be utilized wherever it is. Even you can use it for a small refiner loop to complete a pulp mill operations also. But in phase 2, the profitable automation, the control part. So the control part is more about a specific operational islands. So it can be limited to a bleaching process in your pulp mill. It can be a cooking process, or it can be a power boiler. So that's how the phase 2 happened. But the phase 3 is more about more of a concept, I should say. It's coming up. I mean, all the industry leaders have started talking. Even the suppliers, the high-level suppliers have started talking about sustaining the benefit by having a complete ecosystem in the mill. So it is not just limited to, for example, cooking. Everything will be connected to each other, and they will be adjusting by itself based on the demand. Because sometimes the mill will be more importantly looking for the quality of the output. Sometimes it is more important for the cost. So they should have the gears to switch between these kind of requirements. Yeah, so that was the first part of the discussion for today. And the second part is more about, I was mentioning the tools which can be utilized and some of the case stories. So in this tool, capturing the data, we have been keep saying capturing the data, but why to capture the data? Let's see it on the last column, the result portion, because this has been almost everything is quantified. in an economical sense, and what's the benefit is coming out from this quantification of data. So some of the interesting stories, like the second one, increased human capital efficiency 25%. How it is? I mean, we the same question was there with us also. I mean, how it is possible? Like, we are making it more easier for operators and process engineers and senior management to take a good decision at the earliest as possible. We have seen this in practical sense, saying that, okay, now I don't need so much of time. I'm saving 2 hours or 4 hours during my day-to-day activity, and the remaining time can be extended to the other activity. So this is pretty much visible, which is happening. Maybe some other examples in terms of chemical saving. It's pretty much visible. How it is possible? Smart alarms, because there are certain alarms which is already available in the DCS and QCS system. But if you want to club multiple things together, so you have a variability which is happening in your pulp mill, and that will be definitely hitting you after 4 hours or 6 hours. So if you can have a dynamic smart alarm which is giving you action to be taken upfront, then you will be saving a lot of correction. So these kind of results are possible. How it has been done? Yes, you need the tools for that. Statistical tools, which is user friendly, like to make the correlations. When we say statistical, it is not just limited to the data scientist people. The idea of having these tools is to make it user friendly for the operator level. Ultimately, the operator should become the process engineers. That's the goal. Like the gap between that is like the tool. They don't have enough tool to leverage themselves. So there are plenty of tools available in the market also, and plenty of tools we can also support you with. But these are maybe the loop performance analysis it was keep mentioning. Maybe in the next slide, I will be little bit talking more about that. I have time. So we have been seeing this, the importance of control loop, which is, there is no doubt into that. I mean, all the loops in an industry, in a continuous or a batch process industry, has to be maintained for sure, and has to be controlled also to the optimum level. But the difference comes here is like, whether is it a one-time job or is it a continuous job? To us, it is a continuous job, because one time, okay, I have done it in January, and I'm just hoping that the next 6 months it will be working fine. That is something judgment. I mean, we don't agree with that, maybe. But in this case, what we wanted is like, more likely it should be a continuous monitoring, not just on the loop parameters. There are multiple associated elements. Like, for example, there could be oscillations in the process. There could be stictions in the valves. There could be a limitation in tracing the set points. So all these has to be addressed, and it should be visible to whoever is attending to that. And it should be very flexible for any kind of DCS system, because we have multiple DCS system, latest and legacies. Technically, the tuning parameter changes with the DCS, and even with sometimes with the models also. So system should be capable enough to capture all those data on a continuous basis and make the corrections and give some inputs to do the corrections also. The importance and usage of this one is like, it is not just limited to a paper machine or a mill. Rather, it is becoming a corporate idea. So there are people, I mean, outside India also, we have seen that, not just in paper industry, outside also. We have seen people having a corporate office with this data team, sitting and watching all the loops, because 60% of the loops statistically, which has been counted, that's not healthy. And if you can make that loops also into a healthy, we have seen that there are a lot of changes can happen. It's not just in terms of savings of energies and chemical, but rather the quality improvements also. The next part is more about the generative AI, which we have been talking about. Model predictive controls, multivariable controls, advanced process controls, smart factories, multiple names comes into that, but the general concept remains the same. How do we control a process which is having a complex variability, along with that a time delay? So that's the complexity we are talking about. Something changes, it has an impact after 4-5 hours, and how do we control that upfront? So in this concept, we should have a prediction mechanism. So when we say prediction mechanism, it's not that I should be predicting for the next 24 hours. No, that's not possible. So there is a reasonable prediction, like 90 minutes to 120 minutes is possible based on the delays in the timing. And seeing that, how do you take a control action upfront? That's the challenge, and that's what the AI mechanism should do, and it is happening also. It has been proven. The basic difference when we say the modeling, it's not just about the static modeling. So I can do a modeling based on 1 year past data. I create a very nice modeling, but the next moment the model changes because the variability would be different. So you have to revisit all these models maybe weekly or monthly. That should not happen. When we talk about generative AI or a machine learning, the machine should learn by itself. That's the concept. So whatever the changes is coming, which is dynamic in the process, it should come back to the model and correct by itself. Because that's a thought process behind this model predictive advanced control system. 5 minutes. Some of the steps which has been practiced and made it successful, I am not going through the entire steps. Rather, I would take some critical areas like the integrating the data, because in the Indian paper industry, we know that we have legacy data sources like the old version of TCS and QCS and even the PLCs available. And we do have certain other data sources, not even digital. For example, the LIM system, lab information management system. Some mills are having it, but most of the mills are not having it. They are capturing it in an Excel format. That's fine, absolutely fine. How do we capture that Excel format into the central pool? Because ultimately this has to get compared. Whatever is the process is happening, this has to be compared with the laboratory values also. That's the quality data. If that is not visible and it is not captured well, then we are not making the complete picture. So integration of this data is very, very important, and we should capture everything. That's one of the key steps, and store it with a high resolution. When we say a resolution, it depends. In a boiler control, in a boiler situation, it should be in milliseconds sometimes. The pressure can vary in milliseconds. But in, for example, in the tower levels and all, it can be in seconds, like 5 seconds or 3 seconds. So it should be flexible enough to handle this resolution factor also. And it should be easily accessible. Maybe that video which is showing on the right hand side is saying that, okay, anyone who is using this platform should be able to see what's happening. I mean, as I was keep mentioning, it should not be limited to a group of people. And whatever the data, I mean, it is from pulp mill to boiler to ETPs and environment or the paper machine, it should be visible. It should be made it available to everyone so that they will come up with certain ideas and there will be integrity in the process. One of the major steps was like, okay, how do we find quick wins? We keep talking about the low hanging fruits. So without having correct estimation, at least an approximate estimation of saving potential, it's a risky judgment of jumping into, okay, I can do AI in a paper machine. I think that's a risky judgment. So we should understand whether there is a potential or there is an infrastructure requirement, or your process is absolutely fine. You don't need to touch that area in terms of AI. So we should be able to find out this quick wins by end of this process, so that we can get into the next phase, like the advanced control process and model predictive control. So this may be the three major steps I would like to cover it. But some of the case stories I was promising in the beginning, both the case stories which I'm showing is the Indian case stories. So we don't need to go outside India and ask for this kind of development. We are changing and India is changing. We can see that. In this case, it is a Northern India mill, completely integrated, pulp mill and paper machines and utilities, everything. So the first step they have done is to capture the data from everywhere, like whatever the data source is possible. So there were challenges. I mean, it's not that straightforward. I mean, there were legacy system which is having a connectivity issues, and there are some later systems also which is familiar, but there are laboratory data which has to be connected. It was not that straightforward, but it was made happen. So all these data were captured in a well sent, and how it is being used, and even the ERP system, SAP, it's not a straightforward data format for the technical guys. The SQL system, it's not a continuous data flow, it's a static data flow. So even that is being connected and utilizing for betterment of the process. Maybe some quick glimpse of how it is being used. This is a data for 90 days, easily captured, and as an introduction, this has been done by the customer. I mean, they are doing it, capturing one particular grade. The grade data is coming from SAP system, and QCS data, which is the ash measurement they wanted to get it. and they are comparing for the last 90 days for one particular grade. So, and the idea of this comparison is like how the variability is happening within the ad. So he was judging that, okay, there is a variability of 16 to 19%, which is, he felt like, okay, it is slightly on the higher side. But the story is not ending here. But we wanted to understand what could be the root cause of that. So you can see that, okay, there is a variability for that particular period. Yeah. So this one, the PCA modeling, for the people, principal component analysis and the partial least square methods, which is available, readily available for whoever is using it, and he would be able to understand, I mean, compress whatever the possible root causes into that statistical method, and 2 minutes. Yeah. And they would be able to understand what could be the potential root cause of that. So in this case, he was trying to understand what could be the root cause, what for that particular time period, and what was changing. And interestingly, you will see that with one click, yeah. So with one click, it would be able to say that what was impacting that particular point of time. So you see the contribution mass metrics, mass flow for the PAC mass flow was changing definitely, and the retention aid flow was not accurate enough. So these were the two major changes during that particular period. The others were not largely impacting, but still there is a kind of a correction required, but at least the process engineer and the in charges can jump in and see and attack these areas. So this is one of the example. Another cases, people talk always about the center lining, golden batches, and all those stuff. So very dynamic video which talks about the center lining, which is nothing but critical process parameters. He's been compared with the current running and the earliest run, the past running. And more importantly, it's not just about the comparison. It should be easy enough to switch between the requirement. For the people, sometimes it is the average is required. Sometimes for the management, it is more of a CPK value, for example. That is because just in one click, it is all changing. And you can see what's the difference between the last batch to the current batch in terms of a percentage sense. And it is an indicative mechanism which is happening. Visible benefits. I am not going through everything, but the last two is more important. They have started with 18 in-house improvement project utilizing data. With this core team, no external support. So they are doing by themselves, identified and defining it. 6 projects they are taking. I was mentioning about the low-hanging fruits. 6 projects they are doing in a model predictive control mechanism into the AI mechanism. Number 2 case study is just 30 seconds now. I'll just finish. It is earlier case was all about the complete mill, but this case was in a process area, which is a process island, which is a hardwood pulp mill, and the bleaching sector, which is in the southern part of India. It was more of a control process, like a model predictive control, how we can use this generative AI mechanism to control the ultimate quality of that. We did the control suite, the control loop mechanism. How do we make the loops more healthy? We were able to identify that what is causing the problems and all before tuning and after tuning, which is pretty much visible. The important factor here is the visible benefits in terms of quality, which is on the lower bottom, which you can see. The important area which you have to look is the brightness variability reduction, which is of 59%, close to 60% of brightness variability reduction. And of course, it has been resulting into economic benefits also. So this is some of the case stories, and summary slide for me. Data is useful for sure, and the thought process here is how do we make this data more profitable? I mean, we have to convert that data into create more profit for the organization. That's one thing. What we can see as a challenge is like the cultural transformation. And it's not straightforward. I mean, people has to adapt and change it, but it's just a matter of time. And we can see that the whole audience here, we can see the change is happening, and it's a cultural effort and the change management which people will be doing. I was mentioning that operators becoming a process engineer. The gap is just the tool. They have the brain. They have been sitting in front of the system for 24/7 all his life. Just the gap is the tool to enable them to become a process engineer. So with that, I wish to thank you and listening. Thank you for listening to this session. Thank you very much. Thank you.